Hello everyone. Today we are in position to explore two powerful tools in Python. These are list comprehension and Lambda function. What is list comprehension? This is nothing but list comprehension is an elegant and concise way to create new lists. Particularly, this tool is well suited for two main scenarios. One, for creating new lists based on the existing iterable list, meaning that if we want to build a new list by iterating through an existing squares like lists, tuples, string, or range, and we apply an operation to each element, we can make use of this list comprehension basically. But the second scenario where list comprehension is applied is for filtering and transformation. Right? The filtering scenario can be made through the conditioning logic, where the transformation by itself is the basic syntax which is applied for the basic list comprehension application. Let us see one by one. What's the basic list comprehension? What we need to see is the syntax. Basic syntax of list comprehension is nothing but syntax, which is basic. Basic syntax of list comprehension is nothing but list new is nothing but it is a result of this expression which is applied for every x in iterable collection. This can be list, tuple, range, or string. This is nothing but the basic syntax of list comprehension. But the second scenario where list comprehension is applied is nothing but syntax list new expression is the same. We bring this one here, but we add here a condition for filtering. Condition if else condition, else condition. Right. This is nothing but the syntax for filtering and transformation. Machine transforming purpose. This naming are nothing but the reflection of these activities. The process up to this one is a transformation statement, whereas this if else condition is a filtering statement. Right. So this syntax contains both transformation and filtering. The first basic syntax is nothing but only transformation based on the existing iterable collection. Right. Let us see one example. Example of squaring numbers where the numbers are in a given list. Let's say what the objective is squaring numbers of a list where the list is given. Now what the objective is create a new list from the existing list. So list new is nothing but the list which is evaluated through the expression of squaring numbers x. Squaring is nothing but x times x, the number times the number by itself. For every x in list old, right? Where is this? This list old is given here a number of 2, 3, 5, 6, 4, 8. These are the numbers. So what the intention here is to obtain the square of each numbers which are within the list of old. The square of 2 is 4, the square of 3 is 9, the square of 5 25, the square of 6 is 6. So to obtain this list of squares, we apply this single line. This is nothing but list comprehension. So this list comprehension syntax is equivalent to this one, where the first x times x is the expression that we express it here. 4 is a keyword which is useful for iteration statements. X is the iterator or the loop variable. In is the membership operator and is Python keyword. List old is nothing but the given list. So let us see this one by running hit and shift. So let us see by printing print list new list is printed list new. As a type of this new list is list by self, right? List new, right? Print was a type of list old, also a list, right? By running this one, we come up with this results. So the result of new list is nothing but a list by self, as you can see from this, right? This is a list, but the values are transformed, right, by this expression. Well, the square of 2 is 4, the square of 3 is 9, the square of 5 is 25. So this is nothing but the list of the squares of the elements in the list order, right? This is nothing but one application of list comprehension for transformation or for creating new list from the existing list. Well, the second one is squaring of numbers of a list, odd numbers. Only here we only need the squares of the odd numbers, right? Out of this odd list, we need to have list of the square of odd numbers only. To do so, we use the second scenario expression here, right? This expression x in iterable x, expression for x, this is for x. Therefore, let us proceed. This is already given. Now let us start from list new 2. It is a list by self, x times x. We are expecting to have squares of the numbers, but for x in list old, but if x by 2 not is equal to 0, right? If x divided by 2 does not give us 0, if they give us 0, the numbers we are considering for squaring are nothing but the even numbers, but we need here the odd numbers, where this expression does not give 0, right? This expression evaluates to true if x divided by 2 does not give us 0, is nothing but we are considering the odd numbers to be squared. Now run this one, then let us see the result of this second new list new 2. Wow, this is nothing but list of two numbers, 9 and 25. 9 is nothing but the square of 3, 5 is the square of 25 is the square of 5, and these are the only two numbers which are odd. So this one is nothing but filtering and transforming. What if the squares of even numbers, we change this condition, right? Then let us see what's wrong here. Invalid syntax, where there is an inconveniency to the core line. Wow, there is no divider 2. It is syntax here, right? Now let us see. Now the squares of all even numbers is nothing but 4 6, 16, 64. Let us proceed to see what's the difference here. Using squaring, for example, let us see this one. Let us see this one. Squaring of numbers of a list using regular function or coding function. For example, what the objective here is to obtain a list of the square of each element in the old list. Now let us do the same using the regular function. Now what the list is list of old, but what we need to have is new list, which is the squares of the elements in the old list. Therefore list new regular for x in list old Then s is squaring x times x. This is expression. Then now this s now is to be appended over this word, right? Therefore, list new regular append every result in s. Therefore, let us see what's the result of the new list. Print list new is right. These are nothing but the same result with this one, right? This result was the result of this two code, but here the result of this one is the result of these instructions or codes 1, 2, 3, 4. So list comprehension is somewhat concise, readable, and even perform better in speed, right? These are the advantage of using list comprehensions and the conventional list creation, such as using these iterations through for loops or by forming functions. Now let us proceed to the second topic of today. Was other concise way to create small and one-line function is lambda function. Lambda function is an anonymous function because it doesn't have name. So this function, like that of list comprehension, is concise, readable, and perform better in speed. What the basic syntax of lambda function is given by this word. Lambda arguments, no parameters, sorry, parameters separated by colon expression. What this four terms indicate 1, 2, 3, 4, where lambda is nothing but the keyword, where lambda is Python keyword, which signifies we are creating lambda function, whereas with these parameters are the inputs separated by comma. We may have here as many as parameters, but separated using commas, like that of regular functions. And these two terms are separated by colon, where this expression is nothing but a single expression and implicitly returns value. Through this understanding, we can perform some examples. For example, squaring of numbers of a number, meaning squaring lambda x times x. This lambda function performs taking the argument here, performs or evaluates the expression around here. Then the whole return value through this code is assigned to the variable square. Now, to display what is there in the variable square after having taken in the argument value is given below. Print, for example, square of 5. Recall that when we call the lambda function, which is noted in the form of variable, we may use parentheses. For example, we are invoking this square variable as a function now, right? Square within the parentheses. Now we are taking in the value, which is argument value 5. Now let us see the result. It is nothing but 25. This 25 is due to this expression. This 5 is due to this x. Now this value is returned and assigned to square variable. When we call this square variable, we may use this parenthesis, right? Lambda can take also more than one parameters. For example, add three numbers. In lambda, add three numbers. Lambda x, y, z. Then x, y, z. As the intention here is taking in three values as arguments. We need to add these arguments. Then the return value is assigned to the variable r3. Therefore, what the last thing is printing to see what the result is based on the given argument values. For example, 2, 3, 5. But the sum of 2, 3, 5 is nothing but 10. Right? This 10 value is based on this, due to this one. What this 2, 3, 5 is due to this parameter position. The combination of these two is due to the lambda function. Now the whole return value is now assigned to this r3 variable. Now, bear in mind that when we call this r3 variable, now we consider it as a function when calling r3 within parentheses 2, 3, 5, the arguments, the possible arguments. Now let us see the value, which is 10. Right? With lambda also, we can use lambda and conditional logic. We may use lambda with conditions also. For example, value 1 lambda a b. Then this lambda function is required to return a value which is the smallest value of the two arguments based on specific condition. For example, return a if a is greater than b, b otherwise, else b. Right? What this lambda function does is to return the smaller value of the two in such a way that this condition satisfies. Now it says when we read this one, this lambda function returns value a if a is greater than b, else return b. I run this one, then to see the explicit return value based on a given two arguments. Let us see print value with parentheses. These parentheses are useful to take in these possible arguments. Right? Now instead of a and b, now explicitly we write numbers 5, 2 and 5. Now what's the possible print out value is nothing but 2, right? This is nothing but 2. This 2, this one is 2, now this one is 5. Now 2 is to be returned if 2 is less than 5, right? What if, for example, this one is greater? This becomes what? 5. This one, 5. The other consideration with this tutorial is how lambda works with other relevant functions such as map function, filter function, sorted function too. How lambda works with map function and filter functions, right? Example, lambda with map function. It is economical to make use of lambda with map, lambda with filter, lambda with sorted functions. For example, to make the square of each values of a given list, we may use the following combination of lambda with map function. Given the list A 2, 3, 5, 6, 7, 8. What the interest here is to make squares of each, this 2 square, 3 square, 5 square. So how can we perform using lambda function and map function is? Now what the new list is, list B is list by itself, where it applies map lambda x, where x is the product of x. From where this x comes from is nothing but from list A. Now, this is nothing but the new list B. Let us see the result. This is nothing but this was original list, which consists of 3, 5, 6, 7, 8. Due to this code, this list B is generated in combination with map function with lambda function. Right? This is the lambda function which performs its expression x times x, where each x are mapping from this original list elements. Now this whole expression result is assigned to this one as a list. And when we see the result of this list B, we come up with this one, meaning the square of each element in the list A. This is nothing but due to the combination of map and lambda function. What if we are interested to perform filtering, provided that lambda function is given? Now, filter function with lambda function. This is nothing but, for example, given list A is given once here. Now let us proceed directly to the code. List C, for example, another list is to be created based on this combination filter and lambda function. Now this is also a list, but based on filter function over lambda function. Lambda function is x, but this x is now returned as a value if x divided by 2 is gives with reminder 0, meaning we are filtering all even numbers from the old list, which is given by this one. Right? This is the list. Now based on this one, we are filtering only to return this code the even numbers. And so we use lambda function as usual. But the expression here is, this is a condition, right? This value returns to true if x is even number, right? So this is also made based on this mapping, where these x are come from this list, right? Now let us see the result. Print list C. We expect to have all even numbers 2, 6, 8. If we change this one into not, we are referring to the odd numbers 3, 5, 7. This is effective even if we do have huge data or big data. This is effective code to retrieve or to filter or making maps based on simple conditions, but not beyond that. In case where there is a need of complex logic operations or complex codes, these two list comprehension and lambda functions may be difficult to perform.